So hello and welcome. In this video we are going to discuss about Ohm's law and electrical resistance. So a few more concepts like mean free path, relaxation time, Ohm's law and resistance, conductance, conductivity, mobility, relation between drift speed and current density, means all these small things along with Ohm's law in vector form, and then how to find resistance and resistivity and coefficient of thermal resistance. All these things we are going to discuss in this video. So let us start. In last video you had seen that when no potential difference is applied across the conductors, then in that case what happens is, suppose this was the initial point of electron, so it will move in random directions and then it will again come back to the same point. A and B means initial and final point both were same, and in that case net displacement is how much? Zero, because initial and final point both is same, but distance is not zero. Distance is length of the total path on which electron was moving. So when we write average speed, that is distance by time. Of course, it will not be equal to zero. When we write average velocity, that is equals to displacement divided by time. So since displacement is zero, so this will also be how much? Zero only, right? So there is no drift of the free electrons, thus net current is how much? Zero. Simple. And electrons are moving in random motion, due to which displacement is zero. Now, next is when we have applied one potential difference. So here now battery, you can see this is positive terminal, this is negative. So here negative charge, potential, positive potential. So now of course electric field will be in this direction. So now here initial point of, let us say, charge was A, and now final point is B. So now due to this electric field, we know that electron is having negative charge, so one force will be acting on the electron opposite to the direction of electric field. Now due to this force, there will be some displacement in the electrons. So when potential difference is applied across the conductors, so there will be some displacement in the electron, because there is some external force, we can say, or due to this electric field some force is acting on this electron. So they starts drifting opposite to the direction of electric field, right? So here average speed is of course not equal to zero, and now average velocity, that we call as drift velocity. Average velocity is nothing but drift velocity, and this is also not equal to zero because there is some displacement, right? And when we write average speed, that is total distance by time. Since distance is larger, so of course speed will be greater than, much greater than drift, because drift velocity, because the shift AB, this x is very small, right? Clear up to this part? Now let us move forward. So now drift velocity and current. So here now there are few assumptions which we have to take, that all the electrons, like when we have applied this electric field, so all the electrons are moving parallel to each other and there is no collision between them. Force acting on all the electrons is same only, Q into E. So they all are moving with same constant velocity in opposite direction of electric field, and there is no collision between them. In reality random motion is happening, it is not like that. For simplification we are assuming this, okay? So all the electrons are aligned and move with constant drift velocity without colliding with each other. Example is, we can consider like a march of army. So all are moving in the same direction without any collision. Simple. This is one assumption we take. So now suppose there is n number of free electrons per unit volume. Per unit volume means, suppose this is the part of volume, means length, and area is 1 and 1. So for n number of free electrons are there per unit volume, or free electron density, or the conduction band electron density. So in this case now, if I want to write current, so current will be equals to number of free electrons into electron, that is equals to what? Charge into area of cross section into velocity. So that will give us what? Current. I is equals to NEAVT. Very important formula that we have to remember, right? Clear to everyone? Let us say that in this case this separation is D. So how much time it will take? T time. So if I want to write current, that is equals to delta Q by delta T. So in this time interval how much charge will flow? So that can I say that number of electron into, means number of electron per unit volume into charge on electron into area of cross section into how much length we have taken, x let us say, or L, divided by time taken, right? Now this is the drift velocity. So we can write NEAVT, that is what I. Clear? Now next is a few terms, that is mean free path and relaxation time. So what is mean free path? When electrons are moving, so there will be n number of collisions between the electrons or ions. So the average distance between the two successive collisions, suppose there are n number of collisions. So first collision is how much path it has traveled before next collision. So suppose from here to here it moved and then first collision happens. So L1, lambda 1, lambda 2, lambda 3 and so on. So lambda is free path, how much distance it has covered before the collision. So if I want to find mean, can I say that mean free path, that will be sum of all the free path divided by number of collision. Simple. Now relaxation time is the time gap between the two successive collisions. So when we say average time between two successive collisions, that is called as what? Relaxation time, and we represent it with tau. This is called as tau. So that will be relaxation time for first collision plus second, third and so on divided by total number of collisions. That will give us what? Relaxation, average relaxation time, or relaxation time in general we call it. Simple, easy. Clear to everyone? Now, let us move forward. So next is drift velocity. So in this case, now we have suppose one particle is moving and drift is from A to B. It has moved by distance L. So since we know that magnitude of acceleration due to electric field is how much? So we know that force will be equals to Q times E, and acceleration is equals to force by mass, right? So it will be equals to how much? QE by M, right? So magnitude of acceleration due to this electric field will be QE by M. So by applying law of motion in 1D, because we consider that all these electrons are shifting towards right side with some constant opposite to direction of electric field with some constant velocity, right? So can I say that in 1D we can write velocity initial, that will be sum of velocity of all the particles plus acceleration into time, means we have v equals to u plus at, right? So for first particle if I write, so for first it is u of first particle plus a into relaxation time of first, similarly for second, third and so on. So the average speed attended by the charge carrier in a conductor in a direction opposite to the electric field, and that will be equals to how much? E by m into tau. Acceleration into relaxation time, right? We know now v equals to u plus at. Now initial u was how much? They all were moving in random direction, so net displacement was 0, or initial average velocity was 0. So we can say that now when we applied the electric field, it will be equals to acceleration into time is how much? Tau. So acceleration is how much? QE by m into tau. Q is how much? E, right? So we can write drift velocity in vector form, that will be equals to E tau electric field divided by m. Now E is having negative charge, so we can take care of direction, right? Now if you see NCRT, this is the formula given, and when we are going to this microscopic level, or we can say quantum world, in which we are observing the motion of electrons. So these are very random motions, and the electrons are revolving and then they jump to the next orbit and then it moves on. So since we are entering the quantum world, so the assumptions we obtained for drift velocity is a close approximation. So when I say this is drift velocity, this is one close approximation. So it depends on whatever expression we get. So it depends on what are the assumptions I have taken, right? So that is why depending on the chosen assumptions, the expression of drift velocity can be different. So in NCRT, this is the expression given. So I will be using, or all of we should be using this only, right? That v equals to u plus at. In this case, we assume that initial velocity was how much? 0, and we can write v will be equals to, that is drift velocity will be equals to E by m into tau, right? Now in SCV, one famous book all of you know for physics, they have used drift velocity that is equals to half of E by m into tau. Now you all know that drift velocity that is equals to displacement by time, yes or no? Now if particle has some acceleration, so can I say that displacement will be equals to ut plus half at square. Now again initial speed was how much? 0. They were moving in random direction, so net displacement was 0. So net average velocity was also 0, right? So here now we can write displacement is how much? Half A is how much? EE by M into tau square. Yes or no? Now we can put this value here. So it will be equals to how much? Half EE by M into tau square by tau t na. So this one tau gets cancelled and we get V average or drift velocity, that is equals to half EE by M into tau. Now both expressions are correct, but when it comes to application part, we will be using this which is given in the NCERT. Clear to everyone this difference? Why we are getting different? Because in quantum world nothing is absolute. So whatever assumptions we take, it depend on that we get the result, right? Clear? Let us move forward. Next part. So next is Ohm's law and resistance. You all know Ohm's law from last from 8th class, I think, or 10th class, definitely, right? So what is Ohm's law? Ohm's law is, now first we had current formula. This is very important formula, that is equals to NEA VD. So and we know that VD is from NCRT we are taking. So EE by M into tau, right? So combining these two, if I replace VD from here, we want to find the derivation of Ohm's law. So can I say that V, combining these two, can I say, or let us write one more line. So here let us write. So can I say that I will be equals to N E A. Now VD we can write as E E by M into tau. Yes or no? Now we know that, can I write this E in terms of voltage? So it will be, can I write multiply and divide by L. So total length of this wire we considered L, electric field is E. So potential will be equals to E dot dr or EL we can say, right? So this E and L, that will give us what? V. So if I want to write V by I, we have taken the reverse. So that will be equals to M into L divided by N E square tau into A. Yes or no? Just simplified. So this result. So V by I, that is equals to ML by NE square tau A, or we can write, now here see, mass of the electron, length of the wire for given wire, if we don't change the physical dimensions, number of free electrons, charge on electron, relaxation time, area of cross section, all these things is constant for one conductor. Yes or no? So we can say that V by I is constant. This is what Ohm's law says, right? So now we can write this constant as resistance R, or it is also called as electrical resistance. So R will be equals to this value. So M by L, M into L, sorry, M into L divided by N E square tau A, right? And SI unit of resistance is ohm. We represent with omega, ohm, right? Simple, easy. Till this point, no problem. Now, so what is the statement of Ohm's law? So Ohm's law says that potential difference across a conductor is directly proportional to the current through it, given that the temperature and other physical factors remains constant. So if you write up to this, then half marks you will get. We have to write both parts. Potential difference across conductor is directly proportional to the current. So V is directly proportional to current, keeping the temperature as constant, and other physical quantities like length, area, these should also be constant, right? So we can write V is proportional to I, or we can write V equals to, when we remove this proportionality sign, some constant, so Ri or IR, right? And R is how much? ML by NE square tau A, right? Now here, see, L and A is what? Dimension quantity, means we can change the length of the wire or area of cross section. Now this part, M by L is there, M by NE square tau. So this term we call as resistivity. So now if I want to write, so R will be equals to, this is rho L by A, right? So SI unit of resistivity will be ohm meter. Simple, easy. Clear to everyone? Now here see, when we say resistivity, rho, that is equals to m upon n e square tau. So m is mass of electron, n is number of free electrons per unit volume, e is charge on electron, tau is relaxation time. So for a given conductor, this will be constant only, rho will be constant, yes or no? If we don't change the temperature, then it will be constant for the given conductor. So we can say it is property of conductor, right? Now, let us see more about conductance and conductivity, opposite of resistivity. So conductance is 1 upon resistance. So its unit will be ohm or mho, mho. Similarly, conductivity, that is 1 of resistivity. So it is 1 by rho. Unit will be ohm per meter or mho per meter. Simple. 2 points you have to remember. Sometimes in question they will give you conductivity. So resistivity will be what? 1 upon conductivity, we represent it with sigma, and conductance we represent with G. So G is nothing but 1 by resistance, and conductivity is nothing but 1 by resistivity. Simple. So now next is mobility. So what is mobility? Let us see. So mobility is, it is the value of the drift speed per unit area of electric field strength, that will be called as mobility, and we represent it with mu. So mu will be drift speed per unit electric field. So we can say that mu will be equals to V drift divided by electric field. Now speed, drift speed, that means magnitude of drift velocity. Simple. Now you all know that what is drift velocity. V drift, that is equals to QE by m into tau, right? So we can put the value. So E will get cancelled, and we have electron, charge on electron into tau divided by m. Simple. Just remember this formula: drift velocity divided by electric field strength. How much electric field we have developed across the conductor? So that will give us what? Mobility. So unit SI unit will be what? Meter square per volt second per second. So drift speed, that will be equals to E by m into tau. So we can put the value and we can simplify. Simple. These are small terms, but sometimes in questions they will ask you that some current is flowing or drift velocity they will give, and you have to find the mobility of the electron. So how much is the mobility? So we can say that faster the particles moving at a given electric field strength, the larger is the mobility. Of course, if drift speed is more, then uh, for the given electric field, if electric field is same but electrons are moving faster, that means for that conductor mobility is higher, right? Now next is relation between drift speed and current density, right? So charge crossing through A in time interval t, we can say that charge is what, or we can write Q is equals to I into delta t. I is what? NEAVT into delta t, right? N is number of free electrons per unit volume. So now in this case, current flowing through unit cross section area is what? Current density. So we can write J is delta Q by A into delta T. So we can put the values and we can write current density, or simply we can write, see, I is what? NEA VD. VD is drift velocity. So we know current density, that is equals to current by area of cross section. So we can write NEA VD divided by A. So A gets cancelled and we have what? NEVD. Simple. Yes or no? Clear to everyone? So one formula till now what we have studied is value of current, that is equals to NEAVD, where N is number of free electrons per unit volume, E is what? Charge on electron, A is area of cross section, VD is drift velocity. Direct questions they have asked on this formula, so please remember it. NEAVD, 2-3 times if you write, you can easily remember, right? And the current density, that is equals to I by A. If I write in vector form, so I will be equals to J dot A. Simple. Now, let us move forward. Next is if I want to write vector form of Ohm's law. So we have what V equals to IR, that was the Ohm's law. Now can I write V as E into L? L is length of the wire, right? And I can I write as current density into area of cross section into R is rho L by A, right? Now A we can cancel and we have electric field is equals to resistivity into J. So from here now, can I say that current density that will be equals to sigma into rho. So sigma into E, where sigma is what? Sigma is conductivity, right? And rho is what? Of course, resistivity. Is it clear, everyone? Simple, easy, right? Now, next, let us move forward. So, validity of Ohm's law. So, there are two kinds of material. For us, only ohmic conductors we are going to see. So, for ohmic conductor, the graph between V and I and V is constant because see, we had V equals to IR, right? So, if I want to write the slope for this, so slope will be what? I by V. So I by V that will be equals to what? 1 by R, right? So that will be constant only. So for ohmic conductor, the slope of the graph will be constant. So material at low voltage and current like temperature, other physical quantities remains constant. That will be that will behave as the ohmic conductors. Next is non-ohmic conductors. Non-ohmic conductor means the materials which doesn't follow the Ohm's law. So in that case, as voltage is increasing, current will increase in this way. So at different points, it is not constant. So of course, resistance is also changing. That example will be semiconductors, right? So materials, ohmic conductors, non-ohmic conductors. Ohmic conductors are, we can say, all the metals mostly. Non-ohmic conductors means semiconductors which doesn't follow the Ohm's law. Non-ohmic, simple, right? Clear to everyone? Next, let us move forward. So let us see calculation of resistance. If I want to find resistance, we have the formula that is R equals to rho L by A. So if the conductor is given, resistivity is of course given, length and area of cross section is given for different materials, how we can find the resistivity. So let us see. Like here one case is, now see this wire is showing you the direction of flow of current. So when I write R that is equals to rho L by A. Now here A is area of cross section. Which area of cross section? So suppose if this was the wire. So area of cross section which was perpendicular to the direction of flow of current. Yes or no? L was what? Length of the wire along the direction of flow of current, right? So by keeping that in mind, we can find the resistance for different cases. So here current is flowing in this direction. So length along the current flow is how much? A. So when we write rho L by A, so rho is rho only, L is A, and area of cross section will be this part, right? So that will be A into B. Simple. If current is flowing in this direction, so now length is how much? C. So rho C divided by AB. This part is now our area of cross section. Simple. Third is if current is flowing from up towards down, means take one cuboid and then you can consider these cases. So in this case now length along the flow of current is how much? B. So rho B divided by, now area of cross section is this part, that is A into C. Simple. So when we write R that is equals to rho L by A, rho is of course resistivity, L is length along the direction of flow of current. A is area of cross section that is perpendicular to the direction of flow of current, right? So here resistance of the conductor that depends on the material and temperature, that means rho, this is for rho. Then dimension of the conductor that is length and area of cross section, and direction of flow of current. So if direction changes then rho and L that will change, right? So direction of flow of current which depends on how the potential difference is applied. Yes or no? So materials conductance or conductor depends on these things. Resistance of the conductor depends on these things. L is in which direction we have to take L. L is length parallel to the flow of the conductor and A is area perpendicular to the current flow. These things we have to keep in mind. Simple, right? Now let us solve one question, one good question we can. So let us solve this question. Question says that a conductor of length L has a circular cross section as shown. The radius of cross section varies from A to B. The resistivity of the material is rho and B minus A is very small compared to length of the wire, so that we can neglect if there is any errors and all this. So here we have the formula R equals to what? Rho L by A. So rho is resistivity, that is given. L is length of the wire, that is also given. But problem is there with area of cross section. So if I take at this point area of cross section, let us say A1, so that will come out as how much? Pi A square. Here if I take area, so A2, that will be equals to pi B square. So which area we should take? So we know that when there is no uniformity, there is some variation. So what we do is we consider one small element. So let us say at a distance x, we have taken one small element of thickness dx. So at a distance x, we have taken this thickness as dx. Now for this element, let us say radius at this point, radius is how much? Let us say r, right? Now, let us say here now, if I, for this small element also, if I take these 2 points, so here there is some change in radius up to this part, right? If we elongate, so this was, let us say point A and this was point B. So A to B, there is some small change, right? So let us say this small change is dr. This angle is theta, right? So can I say that this angle and this angle will be same only from this triangle? Yes or no? If I take one more angle, so it will be same only, right? So if I want to write tan theta, can I say that tan theta, this length is how much? Dx. So that will be equals to dr by dx, and that is from bigger triangle. Can I say it will be equals to, this length will be how much? B minus a. So it will be B minus a divided by L. So can I say that dr will be equals to how much? So dr will be equals to B minus a by L into dx, yes or no? So can I say that dx will be equals to what? L divided by B minus a into dr, yes or no? Why we are doing this? Let us see. So here now for this small element, can I say that resistance will be how much? Can I say that dr will be equals to rho L by A. Here L is how much? So rho L for this element is dx in the direction of flow of current dx. So rho dx divided by area of cross section, that will be equals to how much? Pi r square. Now problem here is this dx, x is also variable and r is also variable. So if I want to do the integration to find the net value, what we have to do? We have to do the integration. So can I say that r will be equals to integration of rho dx divided by pi r square, right? Now we cannot do integration, so what we can do is we can replace dx by this value, right? So we have rho by pi L by B minus A into dr by r square. Yes or no? And r is from where to where? So we can say it is from A to B. So limit is from A to B. So now simplify. So rho L pi B minus A, all these terms are constant. So we can take them out. So rho L divided by pi B minus A, that is constant. Now integration of 1 by r square is what? Minus 1 by r. Limit is from A to B. Hope it is clear to everyone. So we can write it as rho L divided by pi B minus A, and this we can write it what? Minus B minus of minus 1 by A. So we can write 1 by A minus 1 by B. Yes or no? Now take LCM and simplify. So we can write rho L divided by pi B minus A into, now if we take LCM, so that will be equals to AB, and in numerator we will have B minus A. Yes or no? So this term we can cancel and we have one simple formula. So here now we got R that will be equals to rho L divided by pi A B. Now see, if I want to remember this in simple terms, if I don't want to remember this derivation, what we have, rho L by A. So area is what? Pi R square. So we can write pi R into R. So radius one is how much? A, another one is B. So pi AB, and we can replace area by this, and that is our answer, right? Simple, easy. Now next, so here what we have done, same thing they have done. So here now length is A, and radius is A and B are two different things. Dr is rho ds upon pi r square, and dr is we can find, and then we can put the value and we can do the integration, which we have already done. So resistance is rho L by pi AB. What we have done, that is correct, right? Simple, easy. Now, next question, let us solve one more question. Question is, given rod has resistance R, this rod was beaten such that its length became 1.5 times of its initial value. So what will be the new resistance of the rod? So initial length was L, now it was beaten, or we can say stretched, and now length became 1.5 L. So in this case now, initial, let us say, area of cross section was A, now area of cross section will change, yes or no? So let us say this is A dash. So how to find A dash? A dash they have not given, but we know that volume of the rod or the material, that is density of material is same. So mass is same. So mass is volume into density, right? So density is same. So volume should also be same. Yes or no? So we can say length into area of cross section, that will be final length, that is 1.5 L into A dash. So from here we got A dash, that will be equals to how much? L we can cancel. So it will be how much? A dash is A by 1.5. So that is nothing but 2A by 3. Of course, area is decreasing, right? Now, we know that resistance R dash, that will be equals to rho L dash divided by A dash, right? So rho L dash is how much? 1.5 L. So 1.5 L divided by area is how much? A by 1.5, right? So A by, or we can write this value, so 2A by 3, like this, yes or no? So now we can write, simplify this into 10. So 5 to the 5 3 the, so it will be equals to 9 rho L by 4A, yes or no? Now rho L by A is what? Resistance given in question. Here resistance was how much? Rho L by A. So can I say that it is nothing but 9 by 4 R? Yes or no? Simple, easy, right? So in this case, as volume remains same, because density is also same, mass is same, so L into A, that is final length into final area of cross section. So we can simplify, this is our answer. Simple, easy. Now, next is there are some general results. So in previous case, what we had seen is how much was the change in length? That was 1.5, 3 by 2. So change in resistance was how much? 9 by 4 R. So can I say this is nothing but N square. So in general, if the length of the rod is increased by a factor of N and volume is constant, if we add some more extra volume or wire, then it will change, right? But if we don't add, only we have elongated or compressed. So if increases or decreases by factor N, volume keeping the volume constant, then resistance will change by a factor of N square. Simple, we can generalize this result. Next is now resistivity. So resistivity is, we know resistance is rho L by A, and resistivity is mass of the electron divided by Ne square tau. Now if we change the temperature, then what happens is that velocity or drift velocity of the particle will change, or number of collisions will increase, so tau will decrease. Yes or no? So electric resistivity rho of the material depends on types of the material and temperature. So if we have one type of material and we change the temperature, so in that case density will change. Yes or no? Sorry, resistivity will change. So sorry. So like for material like conductors, no need to remember these data, not important. For conductors, resistivity is 10 to the power minus 12 to 10 to the power minus 16. For semiconductors, it is 10 to the power minus 5 to 10 to the power 5. See the variation, it is very large, right? In case of insulator, it is 10 to the power 5 to 10 to the power 16. So resistivity is very high in case of insulator, so they don't allow to flow the electrons or to flow the current, right? Now, next is in case of conductors, we have rho that is m upon n E square tau. So, if we increase the temperature, then tau will decrease. Relaxation time will decrease, collision will increase, right? So, if tau decreases, that means rho will increase, yes or no? So, as the temperature of a conductor increases, the thermal energy of the electrons increases, which in turn increases the randomness in their motion, and of course, collision will be happening. So, hence, average time interval between two successive collision, tau will decrease, right? If tau decreases, in that case, of course, resistance will increase. So, resistivity of a conductor at any temperature T, we can say that resistivity final that will be equal to resistivity initial into 1 plus alpha delta T, where alpha is called as the coefficient of thermal resistivity. Okay. So we know that resistance is equals to rho L by A. So L and A is almost constant if we change the temperature. That is not very significant. So we consider length and area of cross section is same. So R is directly proportional to rho. So we can say resistance of the conductor at any temperature T. So if there is change in temperature delta T, so it will be equals to initial resistance into 1 plus alpha delta T, right? Here we neglect the effect of length and area because coefficient of thermal expansion is less compared to coefficient of thermal resistance. So the we can say number by which rho is changing, it is very large compared to L and A change, right? For semiconductors, alpha is negative, means in this case when we increase temperature, then resistance is increasing. For semiconductors, this was for metal. So for semiconductors, if we increase the temperature, then resistance will decrease because alpha is negative. Simple. Now temperature coefficient or of resistance alpha, what is alpha? So temperature coefficient of resistance alpha is generally defined as the change in electrical resistance or resistivity of the substance with respect to per degree change in temperature. So d rho that is equals to alpha rho dt, rho is resistivity here. So alpha we can say that is d rho by rho dt, or we can say that alpha will be equals to dr by r dt. Yes or no? Alpha is positive for conductors and it is negative for the semiconductor. Simple, easy. So this is all from today's class. In next class now we will discuss some questions on thermal resistivity, means if we change the temperature then how resistance of the conductor changes. Okay. So please all of you do solve questions because without practice we cannot learn physics. All the things you know, so please practice. If there is any doubts, we can discuss that too. Okay. So, and any feedback suggestions are always welcome. So, thank you everyone. Bye bye.